Hello everyone, let's start part 2 of chemical reactions and equations. That is types of chemical reactions. So there are mainly 5 types of chemical reactions. They are combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation and reduction reaction. Now let us study all of them in detail. So the first one is combination reaction. So all those reactions in which two or more products leads to the formation of a single product. You need to note down that you will have only just one product. Then all those reactions are referred to as the combination reaction. Let's look into few examples. That is formation of slaked lime. When calcium oxide reacts with water, it leads to the formation of calcium hydroxide with the release of large amount of heat. So this is an example for combination reaction. You can see here there are two reactants which is combining to give a single product. Now this calcium oxide, the common name is quicklime, and calcium hydroxide, its common name is slaked lime. Just for knowledge, I would like to tell you that this calcium hydroxide is used for whitewashing. It is used for whitewashing. Okay, so how is it used? So when calcium hydroxide, okay, use it for whitewashing. So after 2 to 3 days, it basically reacts with these carbon dioxide in the atmosphere, and after 2 to 3 days, it leads to the formation of calcium carbonate. A thin layer of calcium carbonate is formed on the wall, which gives it a shining appearance. So you just whitewash the wall with calcium hydroxide, and after 2 to 3 days, due to the continuous exposure of the wall to the open atmosphere, it reacts with the carbon dioxide to the formation of calcium carbonate, which gives a shiny finish to the wall. Now let's look into a few other examples for combination reaction. So this is not a combination reaction. Please note down, this is not a combination reaction because here two products are formed, and in combination reaction only one product needs to be formed. But formation of slaked lime is an example for combination reaction. Now let's look into the second example, that is burning of coal. Coal is basically carbon. So when carbon reacts with oxygen, it leads to the formation of carbon dioxide. So here you can see only one product is formed, so it's a combination reaction. Now the third example is formation of water from hydrogen gas and oxygen gas. So when H2 reacts with O2, it leads to the formation of water, H2O. Now if I balance the equation, okay, this is the balanced form. Hope all the other equations are also balanced. So this is all about combination reactions. Now let's move to the second type of reaction, that is the decomposition reaction. So what is the unique thing in decomposition reaction? So all those reactions in which a compound splits to form two or more simpler products. Means a reactant is breaking down to give us two or more simpler products, then all those reactions are referred to as decomposition reactions. Now let us take few examples. Like say here, I have got ferrous sulfate crystals. It has got 7 molecules of water of crystallization. We'll study this in the later classes. So when you just heat, this triangle is the symbol for heat. So when it is heated, it gives us FeSO4 plus 7 molecules of water. It loses its water of crystallization. And on prolonged heating, that is if I continue heating, then this ferrous sulfate, this is ferrous sulfate, it further breakdowns to form Fe2O3 iron oxide plus sulfur dioxide and sulfur trioxide. These two are gases, so I am representing it with an upward arrow. Now there are further 3 types of decomposition reaction. See, decomposition reaction is an endothermic reaction. It requires energy. Energy is absorbed during this reaction. So we have classified the decomposition reaction into three types based on the energy that it is absorbing. See, in thermal, that is thermal decomposition reaction, photochemical decomposition reaction, and electrolytic decomposition reaction. In thermal decomposition reaction, basically it is absorbing heat energy for the decomposition process. In photochemical, the light energy is being absorbed for the decomposition process. And in the last, that is the electrolytic decomposition reaction, the electricity is being used for the decomposition process. Now let's study each of them in detail. So the first thing is a thermal decomposition reaction. Means thermal decomposition reaction are those reactions which break up or decompose on heating means heat energy to form products. Now let's study each of these examples. These examples are very important. They are usually or often asked in the exams. So decomposition of lead nitrate. Lead nitrate formula is PbNO3 twice. Lead nitrate decomposes to give lead oxide PbO plus nitrogen dioxide NO2 and oxygen gas O2. This NO2 is reddish brown in color. It is a reddish brown gas. Okay, see in this picture you can see they have depicted the gas with some red color. Okay, because it's a reddish brown gas. So here see we have the lead nitrate here. We have the lead nitrate. Hope the text is visible to you. So when this lead nitrate is heated, you can see the brown fumes is evolved. Brown fumes is evolved. Next, let's study the decomposition of calcium carbonate. So calcium carbonate, CaCO3. So heating, you have to write the symbol or you can write heat. Both is fine. Heat also means the same. Okay. On decomposition of calcium carbonate, on heating calcium carbonate, you will get calcium oxide and carbon dioxide. This calcium carbonate is limestone. And you already know that calcium oxide is nothing but quicklime. Next thing is decomposition of ferrous sulfate. I've already given this example to you under decomposition topic. Let me rewrite the equation. Ferrous sulfate, which is green in color, on heating undergoes thermal decomposition reaction to give iron oxide Fe2O3 plus sulfur dioxide SO2 plus sulfur trioxide SO3. And all these are evolved in the form of a gas. So I am representing it with an upward arrow. Now let's look into the next important reaction, that is a photochemical decomposition reaction. So photochemical decomposition reaction is again a decomposition reaction which takes place in the presence of sunlight, or I can say light energy, which takes place in the presence of light energy. So the example for this is decomposition of silver bromide and silver chloride. So silver bromide AgBr. So it decomposes in the presence of sunlight to give silver and bromine. So yes, you can balance this reaction again. Here silver chloride also decomposes to give silver and chlorine in the presence of sunlight. So here this silver chloride is white in color and this white color changes to grey. This white color changes to grey. So due to this property, these two reactions are used in black and white photography. So this is basically an application of this reaction, black and white photography. Now let's move into the next type of decomposition reaction, the last one, the electrolytic decomposition reaction. So if the decomposition is carried out by electricity, then we refer to that decomposition reaction as electrolytic decomposition reaction. For example, if I have water, okay, and if I pass electricity through water, then it decomposes to give H2 and O2, hydrogen gas and oxygen gas. So again balance the equation. Yes, so this is the final result. So we have also completed decomposition reaction now. Now let's move into, okay, we have a few questions here. Now, why are decomposition reaction called opposite of combination reaction? See, in decomposition reaction, you just have one reactant which decomposes to give you two or more products. Two or more products. But in case of combination, it's just the reverse. That is, two or more reactants can be there. Reactants are there, but it is reacting to give just one product. So this is the unique thing about this. Reactants, both of them are opposite to each other. So write equations. We have many examples. So just you can give some few random examples. Like for combination reaction, calcium oxide plus water gives calcium hydroxide, and for decomposition reaction, calcium carbonate decomposes to give calcium oxide plus carbon dioxide. Just randomly I give you two examples here. So this is a detailed answer. You can refer this answer. Next question, one more question. The solution of a substance X, see it's a solution of substance X, is used for whitewashing. So yes, see, if you just remember, calcium oxide, when it is treated with water, you get calcium hydroxide. Means the solution of calcium oxide is used to make calcium hydroxide, which is further used for whitewashing. So that means it is calcium oxide here. They are referring to calcium oxide. Okay, so name the substance X and write its formula. Okay, so what's the substance X? It is calcium oxide. To be on the safer side, you can also mention quicklime in bracket. And its formula is calcium oxide, CaO. Now write the reaction of the substance X named in above with water. So what's the substance X? It's calcium oxide. It is reacting with water. Okay. So then it leads to the formation of calcium hydroxide. So this was an example for combination reaction, right? With the release of heat. This is the answer. Now let's move to the next topic, next reaction. That is the displacement reaction. So in displacement reaction, it's a chemical reaction in which a more active element displaces a less reactive element from the compound. Okay. So how do you know which element is more reactive and which is less? For that, I have mentioned the activity series for you here. So what is this activity series? So here, as you move down, the activity means the reactivity of the metal decreases. Means here potassium is more reactive than sodium. Sodium is more reactive than rest all these metals. Barium is more reactive than all other metals. Calcium is more reactive than all rest. Means the one all the elements which is present below that particular element are less reactive. Now, can I say that sodium is more reactive than potassium? No. Sodium is present below potassium, so I cannot say that sodium is more reactive than potassium. Sodium is less reactive. Okay, fine. You got to know how to study this particular table. But means these activity series. But how do you remember that? For that, I just have a simple remember technique. If you have, you can follow yours. If you do not know such technique, then try if you can understand mine. So that is, I just write it down here. Please stop. We'll be calling me a zebra. Me a zebra. Instead, Niral. Instead, Niral. Try learning how. Learning how Copper Maverick saves gold. Copper Maverick saves gold. Okay, so here P stands for potassium, S stands for sodium, Ba for barium, Ca for calcium, M for magnesium, A for aluminium, Z for zinc, I for iron, Ni for nickel, T for tin, L for lead, H for hydrogen, C for copper, M for manganese, S for silver, G for gold, and the reactivity series is mentioned here. Now see here, iron is reacting with copper sulfate. So iron is present here, okay, and copper is present here. So yes, now iron is more reactive than copper, means this reaction will happen and you will get iron sulfate plus copper. So here copper sulfate was actually initially blue in color. Now its color changed to green due to the formation of ferrous sulfate. Okay. So now try solving the next equation by yourself. See here. Zinc is reacting with copper sulfate. Now let's see the position of zinc. Zinc is here, okay, and copper is present below zinc. Then zinc is more reactive than copper, so this reaction can happen. So you'll get zinc sulfate plus copper. Okay. Now next equation. Lead is reacting with copper chloride. So where is lead? Okay, lead is present here. So you have your lead here, and copper is again below lead. Means lead is more reactive, so this reaction can happen, and you will get lead chloride PbCl2 plus copper. Now the last one. So in the last one, copper is reacting with iron sulfate. Copper is reacting with iron sulfate. So your copper is here and iron is, so here copper is less reactive. So this is less reactive than iron. So what does the definition say? Definition says that more active element displaces less active element, but copper is less reactive. It is not more reactive. So this reaction will not happen. So I can conclude that there is going to be no reaction in this case. So no reaction. Now let's move to the next type of reaction, that is double displacement reaction. Double displacement reaction in the sense the reaction in which two different ions or group of atoms in the reactant molecule are displaced by each other. Means there are basically two ions are basically exchanging. Okay, so whatever is shown in the picture, for that only I am writing the equation here. When sodium sulfate, see sodium sulfate, reacts with barium chloride, means exchanging of the ions happen. So sodium combines with chlorine to form sodium chloride plus barium combines with sulfate to form barium sulfate. Okay, and here the precipitate will be formed and the color of the precipitate is white. So since a precipitate is formed, I can also call this reaction as a precipitation reaction. Next. What do you mean by a precipitation reaction? Okay, just discussed any reaction in which a precipitate is formed. Okay, insoluble solid in the sense precipitate. Any reaction in which a precipitate is formed is referred to as the precipitation reaction. Okay, this is the same equation which we just discussed. It leads to the formation of barium sulfate, a white colored PPT, that is precipitate, and sodium chloride. So this is your white precipitate. Next, lead nitrate. When it is treated with potassium iodide, it leads to the formation of lead iodide and potassium nitrate. Now here lead iodide basically forms a precipitate, and this precipitate has got yellow color. Okay, so color is very important here. You need to note the stuff. Okay, so this is all about the precipitation reaction. Next, the last type of reaction, that is the oxidation and the reduction reaction. So what is oxidation reaction? All those reactions in which either the addition of oxygen takes place or the removal of hydrogen takes place is referred to as the oxidation reaction. Addition of oxygen or removal of hydrogen must happen. So if you see here, so copper, initially we just had copper, but in the product oxygen has added. So this is an example for oxidation reaction. So here copper is getting oxidized. Copper is getting oxidized. Now, next is reduction reaction. Reduction is just opposite to oxidation. So here the addition of hydrogen must happen or the removal of oxygen must happen here. See here, I have copper oxide is treated with hydrogen gas to form copper and water. Now, here I have oxygen in the reactant side, but in the product, the copper has lost oxygen. So, removal of oxygen has happened. So, if it's a removal of oxygen, then it is referred to as reduction. So, here copper oxide, here reduction. So, copper oxide has reduced. Okay. So now from this particular topic, they sometimes ask, write the compound that is getting substance that is getting oxidized, the substance that is getting reduced, or the substance which is behaving as an oxidizing agent or a reducing agent. So whatever be the question be, but the answer must always be from the reactant side only. Okay, product side will not come. Okay, for all the four which I just discussed, that is, see here, oxidation, the substance that is oxidized, reduced, oxidizing agent, and reducing agent. Whatever be out of these four, whatever they ask, always the answer will be from the reactant side only. The product side will not come. Okay, from the reactant only, you must decide whether the given means the reactant is getting oxidized or reduced or is behaving as oxidizing agent or reducing agent. Now, what is oxidizing agent and reducing agent? So oxidizing agent are those substances which is undergoing reduction. So from the above examples, here copper oxide is undergoing reduction. So then I can say that it is an oxidizing agent. So what does it actually mean? It means that the substance which gives oxygen for the oxidation to happen. The substance which is donating its oxygen for the oxidation to happen, or it is accepting the hydrogen for the oxidation process to happen. Means it is basically facilitating the oxidation process. Next is reduction. Reduction means all those substances which is undergoing oxidation. In the sense, all those substances which gives hydrogen for the reduction process to happen, or which accepts oxygen, means removes the oxygen from the reaction. It itself accepts the oxygen for the reduction process to happen. So in the reducing agent, it facilitates the reduction process. So now let's understand what are these, means how to identify the oxidized, reduced or oxidizing agent or a reducing agent from the given equations. Most of the time this only is asked in the exam. Now see in the given equation, sodium is undergoing oxidation. Sodium is undergoing oxidation. Then I can say that yes, sodium is getting oxidized, means the other one must get reduced. Okay. And I said always answer will be only from the reactant side, product side will not come in this. So here sodium is actually accepting the oxygen and is reducing O2. So this will behave as reducing agent. So always the substance which is oxidized will be reducing agent. The substance that is reduced will be the oxidizing agent. Just vice versa. Now, if you have any doubt, let's make it clear with the next example. So here, copper oxide is reacting with hydrogen gas to form copper and water. Now, if you observe here, the copper oxide is losing copper. So, loss of oxygen is referred to as reduction. Means here, copper oxide is undergoing reduction. So, it is reduced. Then I can surely say H2 is undergoing oxidation. So, it is oxidized. See here, hydrogen. It is having no oxygen. But here if you observe, it has gained oxygen. So it is undergoing oxidation. So this is going to be the oxidizing agent. And H2 is the reducing agent. Next, let's see a few more examples. So now here zinc oxide is reacting with carbon to form zinc and carbon monoxide. So here zinc oxide is losing its oxygen, means it is undergoing reduction. So from this you can say that zinc oxide is undergoing reduction. So it is getting reduced. Or in other words, I can say that it is an oxidizing agent. Next, carbon is gaining oxygen. So it is oxidized. It is oxidized. So I can say carbon is oxidized or is a reducing agent. Now one more example. Manganese oxide reacts with hydrochloric acid to form manganese chloride and chlorine gas and water. So here manganese oxide, it is losing oxygen. Am I right? It is losing oxygen. So it is undergoing reduction. So from this I can say that MnO2 is getting reduced, and on the other hand it is facilitating oxidation. So that is why it is an oxidizing agent. Next here HCl undergoes oxidation. Here HCl, here hydrogen has gained oxygen, so it is undergoing oxidation. So from this you can say that HCl is getting oxidized, or in other words you can say that it is a reducing agent. Now let's look into a few more examples. Last two examples. So lead oxide is reacting with carbon to form lead and carbon monoxide. So if you observe here, the lead oxide is losing oxygen, so it is getting reduced. So lead oxide is getting reduced. So in other words, it is the oxidizing agent. And carbon is getting oxidized. See here, it's just carbon, and when it came here, it has gained oxygen, so it is oxidized. So if it is oxidized, then it is the reducing agent. Now the last example. So here you have iron oxide reacting with aluminium to give aluminium oxide and iron. So if you see here, iron has lost its oxygen. So it means it is reduced. And on the other hand, aluminium has gained oxygen. Or I can say that it is oxidized. So from this example, you can say that Fe2O3 is reduced, or in other words, you can see that it is the oxidizing agent. And aluminium is oxidized, or in other words, you can say that it is the reducing agent. So this completes our part 2, and in the next video I'll be discussing, that is in part 3, I'll be discussing the effects of oxidation reaction in the day-to-day life. Please do like, share and subscribe. Thank you.